For 1-5, we're going to be looking at angle pairs and some relationships that they have together. 4 different types we're going to be looking at are adjacent angles, vertical, complementary, and supplementary. Adjacent angles are just 2 angles that share a side in a vertex. Okay? I know that this gives you a lot more definition-wise, but the important thing is it's 2 angles with a common side. Okay? And a common vertex. Those are adjacent angles. So for instance, in our example, angle 1 here and angle 2 are adjacent angles. They share this ray. Okay? And then also angle 3 and angle 4 are adjacent angles. They also share a ray and an endpoint. Okay? Vertical angles. Vertical angles are 2 angles whose sides are opposite rays, meaning that the vertical angles are formed by 2 lines, okay? So formed by 2 lines. That's another way to think of it. 2 intersecting lines. All right, so for instance here, 1 and 2 are formed by opposite rays, are 2 intersecting lines, so they are a linear pair with one another. And then also, we can say that 3 and 4 are a linear pair with one another. They are also formed by intersecting lines. Okay? All right, next we have complementary angles. For complementary, that's just any 2 angles whose measures give a sum of 90. Okay? Any 2 angles whose measures have a sum of 90. That is complementary angles. So for instance here, 1 and 2 are complementary because we're given this mark that tells us that the whole thing is 90 degrees. Okay? And then also A and B are complementary because the measure of angle A plus the measure of angle B is 90 degrees. So those are also complementary. We know that 43 and 47 add up to 90. Okay? So just like complementary angles add to 90 degrees, supplementary angles are 2 angles that add to 180. Okay? So for instance, any 2 angles that form a straight line, any 2 angles that form a straight angle is another way to think of it. Those are supplementary, meaning they're going to add to 180 degrees. So for instance, we know that the measure of angle 3 plus the measure of angle 4 here, we don't know what they are specifically, but we know that they have to add into 180. Okay, they form a straight line there. All right, so let's look at the following example. We're asked a few questions. We just want to know whether it's true or not. So let's look at part A. AFE and CFD are vertical angles. So AFE is here, CFD is here. Well, let's look at that. They are formed by 2 intersecting lines, are 2 pairs of opposite rays. So yes, those are vertical. Okay, and because they're formed by 2 lines. All right, let's move on to part B. BFC and DFE are supplementary. So BFC is this angle, and then we have DFE is this angle here. So they're supplementary if they add to 180. So let's see if they add to 180. We have 28 plus 118. That does not equal 180 degrees. So no, those are not supplementary. And then last one, let's look at part C. For part C, we're asked if BFD, which is this entire blue angle, and AFB, we're asked if those are adjacent. Well, we know they have a common vertex just by looking at the names. They have the common vertex of F, and then they share a common ray FB, a common side. So yes, those are adjacent. And the explanation for that is what I just gave. Okay, they have a common vertex and a common side. All right, next we're going to look at a linear pair. A linear pair is a lot like a straight angle. You can think of it like that. It's just a pair of adjacent angles whose non-common sides are opposite rays. Okay? That is a linear pair. So for instance, in our diagram, AB and BC are opposite rays. So therefore, I know that these two angles form a linear pair. So angle ABD and then angle CBD are a linear pair. Okay, and you can probably tell from the picture that linear pairs form a straight angle, meaning they're supplementary, which is what this postulate tells you. Any linear pair will always add to 180 degrees. Okay, so let's look at an example of that. In algebra, we're told that angle KPL and angle JPL are a linear pair. So this one doesn't give you a picture, but the good thing about geometry, you can always draw one if you want. So we know we have two angles that are a linear pair. So if I draw that, I know that I'm going to have a straight angle, and then let's just do it like this. So we'll call that K, we'll call this point P, this can be L, and then this can be J. Okay? Just so you can get a good visual and have something to look at. So we're told KPL is 2x plus 24, and then we're told JPL is 4x plus 36. So we want to solve here for each measure. Before we can do that, we've got to find x. So if they're a linear pair, we know that they add to 180 degrees. So 2x plus 24 plus 4x plus 36 has to be 180. Okay, that's what being a linear pair means. So that means 6x equals 120. So x here is 20. All right, once we find out, we can find the measure of each angle. So the measure of angle KPL is 2 times 20 plus 24. So that's 40 plus 24, which is 64. Okay, and then the measure of JPL is going to be 4 times 20 plus 36, which is 80 plus 36, which is 116. Okay, so those are the measures of my two angles. With a linear pair, to check your work, add them together. If they equal 180, you know you did it correctly. If they don't, you've messed up somewhere and you need to go back and check your algebra. Okay, last thing we're going to look at is an angle bisector, and we'll be done. An angle bisector is just a ray that divides an angle into two congruent angles. Okay? So just any ray that divides an angle into two congruent angles. So for instance, here AY is an angle bisector. All right? Because we know that those two smaller angles are congruent. Okay, so let's look at this last problem and then we'll be done. We're told that ray AC bisects angle DAB. Okay, so let's draw an angle. We're going to label that angle DAB. It doesn't matter what your angle looks like, really just using this as a visual. And then we're told that AC bisects that angle. So I'm going to get it as closely as I can to look like a bisector. And so we'll label this up here point C. Then we're told that DAC is 58 degrees. So we want to know what is DAB, that entire angle. Well, if AC is an angle bisector, that means that angle DAB, the measure of that angle is simply 2 times the measure of angle DAC. Okay, so then DAB is 2 times 58, which is 116. Okay, so that angle is 116 degrees. So then I can go and bubble that in there. All right, so that's it for tonight. I hope that you took notes. I will see you in class tomorrow.